let's say we have this object right here, a magnet, and we wanted to know the density of this object. We would reach for our equation. Density is equal to mass divided by volume. Okay? And if we wanted to find its density, then all we have to do is find these two variables, because we know that mass divided by volume gives us density. There's not a ton of other ways we know how to find the density of an object, so we need to know those two things in order to figure out its density. We need to know those two variables to figure this out. So if we took our scale, which this is actually a magnet, so I'm not going to put it on my scale, I'm just going to say it has a mass. What if we put this on my scale, and we could find out that it weighs 25 grams. So we find out that this magnet weighs 25 grams when we put it on the scale. Then the next thing we need to do is find its volume. Now there's mathematical equations to figure out every volume of any object, but we have a shorter way of finding the volume as well. In this case, we're going to use our graduated cylinder. So when we find volume of an object and we submerge it in a liquid, when we submerge it or completely submerge it into a liquid, it will move that liquid out of the way, right? And it will take up space. The amount of space that it takes up determines its volume. Right now, if I were to read my graduated cylinder where the water level is at, it is at 37 milliliters of water. If I put my magnet in there and then look at where it's at, it went up to 38.5 milliliters of water. So we started at 37, it went up to 38.5. That increase is the volume of the magnet. So it increased by 1.5 milliliters. So my volume of the magnet is 1.5 milliliters. Now we know the mass and we know the volume, so we can find the density. We just say, okay, every time we see an M, we plug in 25 grams. And every time we see a V, we plug in 1.5 milliliters. And we can do that on our calculators. Anyone happen to have their calculator out? Okay, go ahead. Whoever gets it first, let me know. Okay, Paige. Or no, whoever solves it first, let me know. Okay, Alan. Okay, that sounds right. 16.6 repeated. You may not know the repeated thing. Don't worry about it if you don't. But that's 16.6 repeated. Okay, good. So we got 16.6 repeated. Now, in science, unlike math, we never leave a number blank. Our numbers always have meaning, okay? Or symbol, units. Remember, did I say that in this class? There's no naked numbers? Okay. So, this is a naked number. It has no units. We need to dress it up. It had grams divided by milliliters. And so it becomes, sorry, let me just redo that. Okay, so 16.6 repeated grams divided by milliliters. Okay, so the dressing of our numbers is always whatever came from our variables. We measured in grams, we measured in milliliters, and we took them divided by each other, so it's grams per milliliter. If we had measured in liters, then it would be grams per liter. If we had measured in pounds and milliliters, then it would be pounds per milliliter. But we measured in grams and milliliters, so it's grams per milliliter. And that comes back to our mass, is the amount of mass per given unit of volume, okay? Everyone familiar with what this is? Or maybe if I write it like this. Miles per hour. Miles per hour literally means miles divided by hours. And so hour is your given unit of time. The amount of miles you drive is your distance. You're taking a distance divided by time. That gives you miles per hour. Every hour, you will travel this many miles. For density, every 16.6 grams of mass, you will have 1 milliliter. So if we got 166 grams of this magnet, then it would take up 10 milliliters of volume. If we got 1,666 grams of this magnet, then it would take up 1,000 milliliters, or 100 milliliters. Sorry. So that's what these things mean. Is for every gram or every amount of grams you have, you get that many milliliters. Just like miles per hour. If you're going 60 miles per hour, that means for every 60 miles, you've gone 1 hour. In 2 hours, you would have gone 120 miles. In 3 hours, you would have gone 180 miles. Okay? So our units, our numbers can never stay naked. And, all right. So at this point, it's probably clear as mud, right? So what we're going to do is we're going to practice. I'm going to write a few practice ones up on the board, and then I'll come around and see how we're doing. And then after that, I'll let you do a little lab to practice as well.